Hi again, welcome to the garage. I'm Pierre. This part still about the hammers. We need to make some finishing on the end caps. These little end caps go at the end of the handles like these, to make a more complete finish. Challenging a little bit. You have to watch concentricity from one side to the other, because we're going to machine one side, flip them over, and make this shape on the side here. So if you want something that is evenly spaced from the border, I mean, you gotta watch the concentricity on the rechecking on the other side. So we'll see about that. I've been also cutting. You have to part. Parting. Haha, that's doesn't rhyme really with party. I've been using for the 30 of them, didn't resharpen, I used it all the way through, and never really have any issues. It's a high cobalt steel parting blade, high speed steel. No problems, no issues with it. I'll show you how I use it, and I think maybe you can get a few hints on that. Also, there's a guy called Joe Piesinski. He gives a pretty good tutorial on, he's more theories, more like things to look for, for maybe starting from the real beginning to achieve the parting. Go see his channel. He's got pretty good things on that. I'll put the description below. I also got when you buy blades for parting tools, if you got the high-speed type, get the Cobalt. You got some like Cobalt 5, 8% Cobalt, Momax, Armstrong high-speed Cobalt. These are excellent blades. They'll stay sharp for a long time. They can stand lots of abuse when they're worn on something. Quick regrind on the end. I mean, you're starting new, and it's I'm not even sure. I got those blades I've been having those blades for a long time. I'm not even sure about the current prices on that, but well worth the investment, because CNC lathe will take advantage of these, carbide toolings. They're more stable, and they will feed them the appropriate speed, which are pretty high. These, you run into speeds like 5, 6, 7, even 800 feet per minute. So this is fast. Usually you can't control these speeds on the manual lathe. Pretty rarely though. So you can pretty max out high-speed blade, get very decent result with them. You got different kinds of holders too. I'm using this one, which gives an angle, but I don't mind too much the angle, because I grind to my own fancy. These little holders, they're not expensive, and you can even make them. It's easy to make. You get the blade, put it in there, and then put down many regular blocks. So maybe something. I just hope I haven't lost too many of you. So a lot of talking. Lathe right there, and let's go there and practice what we just talked about. We're starting by facing. Naturally, it's always the first operation we do. Also, I'm using a CNMG insert with 15,000 radius on this. Going to the center. Try to get rid of that little bit, but doesn't matter too much, because I'm giving myself a little bit of room, because I'll be making a shoulder, and I'm going to be coming back. I'll explain to you as it comes. I'm using beeswax. This is pretty good for aluminum, and it's also great for stainless steel. Chips are forming nice, just curling and breaking. This is good. We got about 3/4 of an inch to go for. Second pass, we bring the diameter to 850 thousandths, and things always go pretty good. Give a good finish. Still little curly chips, and sometimes they break, sometimes they don't. Okay, now we go for the 400,000 length shoulder on this. I'll be keeping a little bit of room for finishing at the end. I'll be back after that to do it. A few passes needed.
Always getting good chips on this. That's my preference if I had to choose. Okay, nearing the end. I'm leaving like myself always a 5-10,000 to give a little finishing. Always that beeswax. Sticks good. I mean, it doesn't fly away as much as oil will do. Finishing pass. Finish ends up being pretty smooth on this. I'll be going down to the shoulder, getting in a little bit and pulling back slowly to finish it up. Okay. Sometimes there's a low burr on the end there, so I'll just get rid of it with the insert. There you go. Because these are pretty sharp. Don't put your fingers on that. I had the zero. I zeroed my DRO on the shoulder, and now I'm just coming back and adjusting length to be 400,000. Like very exact. This allows me to machine within about 1,000 pretty easily. Lower file on this. Always getting rid of the burrs. Center drilling the end. Beeswax lubricants are pretty good for when you work with the with stainless steel and things in that sort. Not bad. Okay. This is 400,000. Okay, starting now. When you go in stainless steel, you give a certain pressure, maintain it, and don't let go. That's it. Removing the tools from the chuck just in case you get your hands hurt. I'm lubricating a tap, installing this to the chuck. Turning the motor off. This is going to get in as much as it can. I think it's not going any further than this. Let's get this out. Now I prepared the special tap with bottoming capacity. Put the tap near, just by turning the chuck lightly and just giving it a very light pressure from the wheel on the tailstock. And this is 4-fluted, so you need to go back and forth a few times to avoid snapping it. Stainless steel with taps. Get high-speed steel, good quality high-speed steel, and they don't live very long in stainless steel, so watch they don't snap on you. Okay, that's done deal. Next operation, parting, and guess what I'm going to use? High-speed steel parting blade, and yes, it does the job. Okay, we got another operation to do after this, so the line up by eye. We're moving 150. We need a final of 100,000, and we'll be moving like maybe
giving us another 15,000, 10, 15,000. That'll be good enough. Turning 375 RPMs. Stainless steel with a parting blade made of a high-speed steel. Secret with this, I'm gonna not fool around. As soon as I get in, see, it's gonna go in a few seconds. Giving it the pressure good enough. Sometimes I'm just going to push, release, push, not backing up, just release. Cuts the chips. Push, release, push, release, push, release, push, and I'm not backing up. Push, whoops, release. If you feel it wants to block, sometimes the chip stays on there, that doesn't come out. Pull out, clean up your edge. Push, release, push, up, clean up the edge. Doesn't happen just with with high speed steel. Happens too with carbide. Pushing, releasing, pushing, getting pretty close from the end, and that's not a part you want to catch with your hands. There you go. These parts have been done for the first side, and I want to do the facing and the bevel or chamfer or whatever on the second side. So I need to get as concentric as possible. So I got my 6-jaw adjustable chuck, and I kind of got a half-inch pin there, and adjusted it so I get maybe a few tenths run out on this, so I can make these parts and being as concentric as possible. Okay, in order to do this, I install a depth stop, and I'm gonna calibrate my 100,000 on this. Two ways to calibrate this. I can use the DRO, or the depth stop itself. Touching the face of the chuck, advancing 100,000 there, or make 100,000 from the DRO, and then just touching with the stop there, locking it, checking, yeah, pretty good. Now ready to face, getting on the stop there, which is adjusted, tighten up, and I'm going to use the automatic advance on this. One drop of lubricant, 650 RPMs. Pulling out. Don't want a tool to leave a mark on this when I come in. And how about measuring this? Make sure there's no burr, no nothing on each side. .7, good enough. Needs to be plus minus 2,000s. Okay, next one. Don't have to move anything except the carriage. We'll end up right close to the stop. X-axis always the same place. That's it. Trying to get that brush finish. Double deburr at the same time. I think this does a nice little knob. spanner wrench and be able to tie them up on the end of the hammers. To do this, I made a little jig here. I don't want to spend hours calculating, so there's a V. Oh, I'll show it better. There's a V in here, and I'm moving the V aside there, not having to move the milling machine too much. Holding it, tighten up the vise, and a little bit of oil. Ready to start the machine and dig into it. I'm going to be cranking the knee since I don't have anything to measure on the quill. And also cranking a knee like this is very stable. The knee on this machine must weigh at least 1,000 pounds. I'm going 90 thousandths deep. Bit of air. Moving this aside. When done. There we go. Next one.